Okay, so everyone, today we are going to make a Collatz conjecture. So not literally Collatz conjecture, but we're gonna make a visualization of the Collatz conjecture. The conjecture simply states that does every number, whole number, if it is divisible by 2 or even, then divided by 2. Otherwise, if it's odd, then multiply it by 3 and add 1, or we should say 3n plus 1. Over and over again. Will it eventually reach 1? So today we are going to simply state the lower bound. We'll give it 1. And we are also going to make the graph of the function. But for that we are going to import from matplotlib, import pyplot as plt. So this is gonna give us the plotting library or the matplotlib library, and then we are going to keep track of time using import time. We're going to make a time start equals time.time, and then we're going to make a situation. Wait, we're gonna make the lower bound first. Plus 1, upper bound. We keep everything in time or fast. We're going to just about 10 to the power of, make it 5. So double of that sign is equals to power. That's how you write it in computer. Then for, we're gonna make a loop for x in range, lower bound, comma, upper bound. While true if, right, we're gonna make a, first we need to make a n equals 0. Oh, no. We are going to make a new variable, x equals, n equals x. So n is equal to x, but it doesn't change when the x is added. Oh yeah, and we are also gonna make a counter or steps is equal to 0 for now. It will keep track of all the number of steps needed later on. We are going to make a situation if x modulo 2, right, not x, n modulo 2 is equal to 0, then we assign a new value of n equals to integer of x divided by 2. So keep note that the percentage sign is for finding the remainder of a number divided by another number. It simply states that if n is divisible by 2, then return n divided by 2. And we are at the steps. F equals, okay, so plus equals 1 simply states that steps equals steps plus 1. Then else if x equals to 1, then simply break first, we print steps plus str steps, and then we send a break so the loop simply stops. It will change the true into false, and then it will just stop. Else, final if, so the else is simply if n divided by 2 is not 0, but it's odd, n equals, sorry, this is not x, n equals n equals 3 times n plus 1, and then yeah, the steps. Now if we want to make a graph, we are going to make an array on the top. We're gonna make two array, or should I say that? Array, two empty array, then array dot pen is to get in an input to the array, steps, and then to dot append x. Now simply we plot everything using matplotlib. We already import pyplot as plt, so here should be plt.plot of array2 comma array. So array2 is for the x-axis and array is for the y-axis. Then we simply show the graph. Now we will return the max. We are not making the graph only, we will also find the maximum value where the integer takes most steps. So max value equals str of max of the array. Note that array is the list of steps, so it will return the max value of steps. Well, we could make it like a for loop and then comparing everything, but using the max function is easier. Then we will print everything, max steps needed plus max value. and then print max integer that needs most steps plus str. We're gonna find the index of the max value, so it will return just the index, but we are going to note that the lower bound here is 1. We can simply add 1 here, but it will be better if we just add the lower bound here. And then everything is done. We will simply run the code and just wait for the result. Oh wait, sorry, I forgot to print the execution time. So n equals time.time print execution time equals plus str n minus start plus seconds. You could actually round this by just 3 decimal. Comma 2, then add the integer, the string here. Yep, perfect. Why is it like this? Is it crashing? Let's lower the bound. Let's try with 10 to the power of 3 first. Okay, it's taking really slow. With 10 to the power of 3 is just like 1000, I think. Where does it crash? Oh, I forgot. It's not a pen here, but here. Okay. Sorry for that. Where is it crashing? Doesn't do anything. What? What? It's the Jupyter or something. Wait. I just like type 100. Does it? It doesn't work. Loop is kinda weird. Something happened. Wait, let's see. Let's interrupt it and see where. Oh, it's not m divided by 2, but it's x. Okay, so let's turn everything to x here. This is m. Let's try to run it. Wait, it doesn't. Okay, so this is not n but x. Run. Yep, perfectly working. Yay, so this is the graph of the Collatz conjecture. It only takes 0.36 seconds, which is good. Next step needed 118. And it's actually correct according to Wikipedia that the max number below is 97, which takes 118. And it is 118 and 97. So that's good. Let's try it for 10 to the power of 6, or maybe 5 first. Shouldn't take too long actually. Seeing this tab is kinda satisfying. Is it done? Yay, it's done. 37 seconds takes. Next integer is 77,031. The max time is 350. So that's it guys for the video today. Hope you enjoy it. I'm not trying to prove anything about this conjecture. I'm just making fun graph. But this maybe it's good a visualization of the conjecture. I'll make more video like this in the future. Like maybe I can make a prime factorization app and something related to recursion. Stay tuned. Don't forget to like and subscribe. Thank you very much.